In today's video, I want to introduce you to a 30, 60, 90 triangle. In the last video, I introduced you to a 45, 45, 90 triangle, and I challenged you to find out the relationship between the sides of a 30, 60, 90 triangle. So let's go ahead and get started. So here we have an equilateral triangle, and you'll see why in a minute instead of a 30, 60, 90. So let's go ahead and start. First, let's draw up an altitude from here. Not like that. Let me use my line tool. We're going to drop an altitude. And remember, an altitude creates a 90-degree angle. That's just its definition. So it creates a 90-degree angle down here. It creates a 90-degree angle. Okay, now let's define some of the angles in the new triangle. So in the two new triangles, actually. So let's call this some angle and this some angle. And let's not use variables yet. But first, I want to try to determine if these two triangles are congruent. So I already see a shortcut. Try to find it. Pause the video and try to find it yourself. If you can't find it, I'll help you out. So we know that this line is obviously congruent to itself because of the reflex property. And we know this angle and this angle. So we can establish that these two triangles are congruent by SAA, side angle angle. We have this side, this angle, and this angle. So now we know that these two triangles are congruent. So let's go ahead and define some of the angles. So let's define this as x, and since the triangles are congruent, this also has to be x. And we know that x plus x is equal to 60 degrees. So let's go ahead and write that down here. X plus x is equal to 60 degrees. Okay, and we get 2x is equal to 60 degrees, and then we divide by 2 and we get x is equal to 30 degrees. And so now we have our 30, 60, 90 triangle. And we could have just drew one, but I'll show you why we didn't in a minute. Okay, now let's define these two sides. Let's define that as C and, no, not in the red color. Let's define it as C and C, but in a green color. C and C. So C plus C is equal to 2A. Oh, that came off. Let me move that a little bit. Not there. Right there. C plus C is equal to 2A. So we know 2C is equal to 2A. And if we divide both sides by 2, we get C is equal to A. So now we know that this side right here is half of that side. This length right here is A. Oh, that lined up perfectly. A. These two lengths right here are A. So we know this is 2A and this is A. And let's go ahead and just take half of that triangle. We don't want all of it because, again, we are working with a 30, 60, 90, not an equilateral triangle. Okay, let me scroll down a little bit. And let's go ahead and erase some of this. And actually, we can leave it there. But remember, that is no longer 60. That's... Let me take that out. Our brush isn't working. X is equal to 30 degrees. Let me rewrite that neater. And we got that from our little proof up here. And this side length is A, remember? So now we can use the Pythagorean theorem to find this side because this is a right triangle. So let's call this side, what should we call it? Let's call it B. Okay, so we know that A squared plus B squared is equal to 2A squared. And that's just from the Pythagorean theorem. And we can rewrite that. B squared. And then if we square 2A, we get 4A squared. And we can subtract a from both sides. A squared, not a. Minus 1a squared. They're the same thing. And these cancel out, so we just get b squared is equal to 3a squared. And we can take the square root of both sides. Square root. So the square root of b squared is just b. Remember the principal square root, we don't want the negative square root. And the square root of 3a squared is equal to the square root of 3 times the square root of a squared. And that's just equal to the square root of 3 times a. So now we know b in terms of a. So instead of writing b, we can write square root of 3 times a. Let me write that neater. So now we know the relationship in a 30, 60, 90 triangle. The side opposite to 30 is half of the hypotenuse, and the side opposite to 60 degrees is half of the hypotenuse times the square root of 3. Thanks for watching.